Hi, welcome to DevSecOps Days Singapore. We're going to talk about continuous security by design. Here's the part where I tell you my slides are definitely going to be online, and they are online right now. You can go to robrich.org, click on presentations, and continuous security by design is right here. You can view the slides that we're going to look at right now. While you're there, click on About Me, and you'll get to this page, which talks about some of the things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. I help lead AZ GiveCamp, a charity that builds software for charities who otherwise couldn't afford software services. I do training on Docker, Kubernetes, ASP.NET, Node, and Git. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woohoo! So let's dig into continuous security by design. So continuous security by design. We talked about this guy. Doesn't Kubernetes do this for me? When we're looking at containers, doesn't the containerized platform just solve the security piece? Well, let's look at Kubernetes. Here's kind of a diagram of how Kubernetes works. We see two main inputs for users. Here's a developer using the kubectl command line to get into Kubernetes. Kubernetes will schedule some content and ultimately launch a pod. And here's the second one where users come in through a load balancer and execute content on a pod. Kubernetes' job is to schedule all that work and to get that content going. It's not about securing the workloads between the containers. By default, every container within Kubernetes can reach every other container in Kubernetes. So our software really isn't secure from that point of view. Additionally, what if a pod goes rogue? Kubernetes can evict that pod, but has it already done the damage? Looking at a different way, looking at the container runtime, here's Docker runtime here on the right, compared to a traditional hypervisor mechanism, virtual machine mechanism on the left. Here, we can see that we still have a hypervisor and we have those sandboxes, but there's nothing here about securing these workloads from each other. Every workload has network access to every other container, and they can do what they need to do. So what is Kubernetes? At best, Kubernetes is a cluster of machines. Kubernetes is a firewall in front of the container so that only the ports that we expect will get into the container. But Kubernetes can't secure the processes in the container. That's our job. So what is a Docker container? It has a file system, it has users, it has a process, it has ports. This sounds a lot like a Linux machine. And in fact, a container pretty much is a Linux machine, except, well, a container is meant to be built in a very specific way, to start up really quickly, to live for a short amount of time, and then to spin down. And that's kind of the major difference. It's still a Linux machine, it still has processes and ports and users, but it runs for a short amount of time, and it's built using tools. So, securing containers. By default, every container can communicate with every other container, so we need to work to secure the content in our container to ensure that it's not targeted by other containers or by outside traffic. If you pop the container, you can get to all the rest of the containers in the cluster. So if you lose a container or if you expose secrets within a container, much like securing a Linux box. So threat vectors. We could have a CVE in installed software. We could have a custom app that has a vulnerability. We could have excessive permissions, exposed secrets. We can kind of break these into two groups. Maybe there's a threat coming from underneath, or maybe there's a threat coming from outside. And then, once we've compromised a container, we can kind of think of two main vectors that attackers are going to do. Either they're going to steal content out of the container, or they're going to pivot that to attack other containers. So how do we secure ourselves from that? Well, the good news is because containers are ephemeral, because they live for a short amount of time, then if we need to, if a container goes rogue or gets hacked, we can just evict that container and create a new one. But if they got in, they may get in that same way again. But the cool thing is a container is designed to be pretty much a read-only file system. Once we've scanned the container and we know the contents of it, once we understand the attack surface of a container, then we know it doesn't change. We're not going to change the way we interact with that container. So, types of tests. As we're building a container, we should do unit and integration tests of our code. We should do static analysis of our source code, machine inventory for known vulnerabilities, open source license compliance, and ultimately, the results of all of those tests we should validate against our corporate policy. Perhaps we're not okay with any vulnerabilities in our containers. Or perhaps we're okay with low vulnerabilities or a few failing tests if that means that we get the new feature out on time. Ultimately, get with your organization and understand the capabilities and the concerns here. So let's dig into each of those. Unit and integration tests. There's not much to say here. You know what you need to do? Just do it. Static code analysis. I'm not here to talk about any particular product, but as you grab these slides from rawrich.org, every one of these blue links you can click on to go to that site to learn more about that. So pick a static code analysis tool that works for your organization, for your type of software, for your frameworks, and your tolerance for durability and depth of scan. Again, this is more or less a solved problem. License analysis. Here's two packages where you can Google using these search terms, and that could get you to other products that may help inventory the software and ensure that you're compliant with the open source licenses that you're using. Policy validation. So we take the results of all of these tests and we can now create a go or no-go type of scenario. Do we allow this container to get released, or should we pull back and not release this because it isn't worthy of our cluster? Ultimately, this is an individual piece, and you can choose with your organization where it makes sense to add more leeway or to tighten things down to make sure that they're more secure. So let's do a temperature check. So far, we've talked about all of the standard ways to secure, well, a machine. So where's the serverless? Where's the container bits? And that's where we're going to talk about container scanning. And the cool thing about container scanning, because each container is pretty much assumed to be read-only once it's done, we can scan it at the point where we build it, collect the inventory of the software that we have, understand the vulnerabilities that are there, and then continuously compare that inventory to the list of vulnerabilities to know if our container will be vulnerable or has become vulnerable in the future. So there's two things we want to do. We want to catalog all of the software on the container, and then second, we want to compare that catalog with a list of known vulnerabilities. So when to scan? The cool thing is there's ways that you can hook this into your DevOps process at various steps in the way. You can do it as you're doing a build. Now, this isn't the fastest process, so you may get some pushback. If the goal is, let's get it from developers' hands into production in 10 minutes, you're going to spend quite a few of those minutes here on the container scan. Another way you can go, you can scan the container registry. So perhaps you have a private container registry in Artifactory, or you have a private container registry in Azure Container Registry. You can go scan through all of the containers in that registry, identifying the software in each one, cataloging that, and scanning for known vulnerabilities. Another way is a Kubernetes webhook, and this is really interesting. Let's come back to this one. You can also scan production. You can look through all the containers that are running, any that you haven't scanned yet. You can scan those and assess the concern. The downside with this is that the vulnerable container has been there for some time by the time you discover it in production. So I would recommend you find one of the other places to do it. Ideally, you're doing it in the build pipeline. If you can assume that this is the only way that containers will get into production, then you can scan each container as it's built, and by the time it finishes building, you know that it is safe to run in your cluster. Together with understanding new vulnerabilities and comparing that to the catalog of the containers that you've scanned previously, you understand when you need to take down a container to be able to upgrade it to more secure versions of content. So Kubernetes webhooks. This is particularly interesting because as you take an image and start to launch it as a container in Kubernetes, as you fire up a pod, it'll go through this process and it'll go look at each step and take appropriate action. What's really interesting, here in the mutating spot, we go call out to various webhooks that are subscribed to this event, and they can change the pod definition. Perhaps here's where we add sidecar containers. And then again, validating, we call various webhooks, and each webhook can say yes or no. So we could take each of the containers, run it through our container scanning software, give it a go or no-go mechanism, or validate that we've scanned it previously, and ultimately choose to launch or not launch that pod. This is a great way to ensure that nothing vulnerable can get started in the container. Now we do need to understand ongoing vulnerabilities and perhaps expire containers that become vulnerable because of new vulnerabilities that are exposed. But this will ensure that we can't launch new vulnerabilities into our cluster. We can create a webhook that will validate that this container is correct and only then allow it to launch in the cluster. So container scanning software. Ultimately, get with your organization and choose a container scanning software that fits your budget, that fits your durability needs, that fits your level of corporate sponsorship. Here's some examples that you might use as search terms, but I'm definitely not here to sell you on a particular container scanning technology. Ultimately, evaluate these and find the one that works right for you. Now, unfortunately, to demo one, I'm going to need to pick one. So I'm going to pick Anchor. Anchor? Anchor? Anchor. So I'll demo Anchor. And ultimately, whether you choose this one or a different one, understand that the principles of these carry through all of the software. Your goal is to do an inventory of all the software running in the container, compare that to a vulnerability database, and catalog when your container is vulnerable. So let's dig into Anchor. So Anchor is free and open source. It runs as microservices in containers, and it does both software inventory and then scanning for CVEs of all the software that it finds. Now, it's not doing static code analysis. It's not examining specific files. It's only examining packages. So it will look through both the operating system packages and installed libraries for your software and catalog based on the inventory that you have there. So if you do put one random file into place, yeah, that file could be vulnerable and it wouldn't catch it. Anchor is not fast and the docs are not great. As I was starting to spin up Anchor, I kept getting into places where the docs would refer to other docs that would refer back to the docs that I just came from, assuming that the other one had clarified the piece. Yeah. When I was researching it, actually, when I was looking at lists of software, some of the lists of software gave better getting started documentation than the Anchor docs. But that's okay. So step one in the Anchor docs is to download a Docker Compose file. That Docker Compose file specifies all of the microservices associated with Anchor, and then you Docker Compose up, and now you have Anchor running in your cluster. Well, kind of. A couple of commands. I can Docker Compose exec into one of the containers, or I can pip install Anchor CLI. And now I have the Anchor CLI, so I can run commands. The Anchor CLI, perhaps I'm pip installing this into my build agent so that now I have that available to be able to launch into my container scanning in my DevOps pipeline. So the first commands that they suggest that we run, Anchor CLI system status, and Anchor CLI system feeds list. The first one will tell us, yep, all of the microservices are running, and the status will show us as it downloads the details of all of the vulnerabilities that it's going to use to catalog. It will automatically update these when it needs to, but this process is not fast. The docs say it may take 10 minutes to populate all the scan data. It took me closer to a week. Your mileage may vary, but the good part is once it is updated, then Anchor will keep that updated in the background, and so you won't need to worry about it. But it does take a bit to get started with this. Next up, what do I do to build out my either my build script or the DevOps process to do this? And the Anchor docs suggest a couple of things. First, we're going to add the image to Anchor as an image that it wants to scan. This doesn't actually do the scanning, but rather queues it to be scanned. We can choose to wait for that scan to finish. This is great in a DevOps pipeline, but in another process, we may want to just look through the registry, submit all of them to be scanned, and come back later and look for the results. So let's add our, creating a DevOps pipeline here, let's add our container to the to be scanned. Let's wait for that scan to happen, and then let's get some results. We can get the summary just by saying image get, passing in that image name. And then we can ask for vulnerabilities and also content. Now, the cool thing about listing the vulnerabilities and the content, let's take that content and let's save that off for later. We can use that to continuously compare this to a vulnerability database, and then we know if the container suddenly becomes vulnerable and we need to expire it and rebuild it. The vulnerability list is great for right now. We can make that go or no go decision right now and say, no, there are too many vulnerabilities in this container. I'm not going to let it through. Anchor also works with GitHub Actions, and we're going to dig into this in the demo. GitHub Actions might be a simpler way to do that because GitHub Actions maintains the Anchor database, ensures that that database is always up to date. And so we just hit it with a single command that says, hey, go scan my thing. Then we can go look at the Anchor reports to try and dig into the vulnerability list and the content list. So let's do that. Let's demo Anchor. So I've got the Anchor set up here. Docker Compose will list all of the content associated with the Anchor engine. And what I notice about this that's kind of interesting is all of them are the Anchor engine, all of the containers. So if I've got all of the content in one container, why am I spinning up lots of microservices? Here's our build.sh. And we want to add Anchor to it. So we're Docker building the container, and then we'll push it to our registry and ultimately kick off our thing in Kubernetes. Now to add the container scanning details, I'm going to go add it. I'll also add the Docker file. I'll wait for that to be done. I'll harvest the list of vulnerabilities, and then I'll go compare that to the policies that I've got in my system. Perhaps this vulnerability list is okay. Perhaps I'm not going to accept any vulnerabilities and I should just kick it off straight away. I'll grab the content. I'll save both the vulnerability list and the content for later so that I can continuously compare this content to list of new vulnerabilities. And ultimately, if that succeeds, now I'll push my content up to my Docker container registry. So we can see that setting up those steps is decently involved, but that's totally okay. On the GitHub side, here's that mechanism. I'm going to create a .github folder. I'll go into workflows, and here's my docker.yaml. Now this YAML is the build steps associated with doing the build here in GitHub Actions. I'm going to hit edit, and now we have this wizard that will help walk us through all the details, which is really, really cool. So checkout, then I'm doing my Anchor scan, then I'm going to go echo all the results just to the build log so that I can see all of the files. I'm also going to grab that Anchor reports folder and use that as a build artifact so that I can just keep track of all of the things. And then finally, I'm going to see if there are any vulnerabilities. In this case, I'm looking for any vulnerabilities, and if so, I'm going to fail the build. Now this happens before I push it up to the container registry. In this GitHub Actions suite, I'm actually not pushing it up to the registry. But I have two repositories here, one for a passing site, one for a failing site, and we can take a look at the content in there. So each one produces these Anchor reports, and as I pop open those Anchor reports, I can see that list of vulnerabilities. here's the vulnerabilities that we found in that failing container. And each one identifies the CVE. It identifies, is there a solution to this? And so that can be really, really helpful. As we look through the content, here's the content of everything. That's kind of big. But we can also get the content. In this case, there are no Ruby gems. There's no Java jars. But we do have some NPM libraries. And so we can use this as that list to harvest and continuously compare this to our vulnerability database. So ultimately, we didn't have a super lot of time to dig into a lot of things, but you can grab the past demo or the failed demo from GitHub, and you can do what you need to do. Final closing words, Kubernetes only protects itself. We secure the containers. Use container scanning to get a hold of this, and add that to your list of tasks in your build pipeline. I'll join you now for questions and answers in the way that the conference has made available. Thanks.